Hi, welcome back. I'm still doing recordings from home. As you can see, the background is my daughter and I's painting work surface. We've got stains all over the back of it. Anyway, so we are going to be doing the walkthrough of 10-1 circles and circumference. You will need your notes with you so that you can refer back to definitions. Oh, excuse me. And let's go ahead and get into this particular worksheet. I am using the large font version just so that it's easier to see on screen for you. Yours is going to look slightly different if you're using the small print version. All right, here we go. Looks like for exercises 1 through 6, 6 may have gone onto a different page, but that's okay. So we're going to look at this figure, circle P. So again, this symbol meaning circle. It's a circle with a dot inside of it because that dot denotes the center of the circle. This capital letter P tells you that the point in the center of the circle is the letter P. So here it is. Here's the circle, and there's its center, P. Number 1 asks you to name a radius. This is requiring you to go back into your notes and recall what the definition of a radius is. So as you're flipping back through your notes, we find that the definition of a circle is going to be a segment where the point is on the circle and the other endpoint on the center of the circle. And so here is from our vocabulary matching that you should already be done. Here's the definition for the radius. So I'm going to zoom in a little bit more on that. It says a segment from a point on the circle or sphere when we go into third dimensions to the center of that item. So let's find the center. There it is. And then connect to every point that we see listed on the circle. So there's one radius. We could also have gone here for another radius. Here's another radius. Suppose if we wanted to get fancy, yes, there is no line drawn between these 2 points, P and E, but you can imagine that there is one, and in fact, when we were looking at line segments, there's a line segment between any 2 points anywhere out floating in space. So that is also a legitimate radius. There's one more that wasn't mentioned, but you can totally see how that you could find the fifth one. Let's look at number 2. Number 2 is asking you to find a chord. Let's find out what the definition of a chord is. So take a moment right now and go back through your notes. Try to find, whoa, I knocked my paper around. Try to find that definition of a chord as I am flipping through my definitions here to find the definition of a chord so that we can see it. Oh goodness, why isn't it showing up? Okay, well, I can't find my little cutout, so I'm going to go ahead and just keep talking. A chord is going to be, by the definition that's in your notes, a segment where the 2 endpoints of the segment end up on a circle. There it is, segment whose endpoints lie on the circle, which means any segment that goes from one point on the circle to another point on the circle can be the name of a chord. We have one drawn for us that's going to be between D and E. There are a few more between any points on the circle, so name any segment that you want. Just don't include the letter P and you'll be fine. The next item says name a diameter, and here we go. Here's the definition for a diameter. It's a chord that contains the center of the circle. So as long as you know that this center P is collinear on the same line as some chord in the circle, you'll be fine. So take a moment, locate one of the chords that you may have identified from number 2, and find the one that also contains the letter P. In naming the diameter, you want to name the endpoints, but just make sure that the center is on the chord. You don't have to name the chord. Number 4 asks you to name a radius that's not drawn as part of a diameter. So again, you're going to be looking at your definitions of radius, a segment that goes from a point on the circle to a point in the center of the circle, and you're going to be looking at what a diameter is. So you're going to name a radius that's not drawn as part of a diameter. So make sure that when you're looking at it, you grab the one that isn't showing as part of a diameter. All right, number 5 asks you to suppose, that means pretend, that the diameter of this circle is 16 centimeters. It wants you then to calculate the radius. You'll go through the video that is labeled radius and diameter for a walkthrough on which formula you would use and how you would set that up. I'll put a link on screen right now directing you to that video if you need help using that formula. All right, let's look at question number 6. There it is, and I very helpfully, very kindly reprinted the figure for you so that you have it. Here it says, if segment PC equals 11 inches, that means the distance between point P and point C is 11 inches. They want you then to find the measure of segment AB. A couple things that you need to do before you can get this set up is figure out what PC even is. No, I'm not talking politically correct, but in this circle, what is the segment PC? Looking back at your definitions, this segment PC is a segment that goes from some point on the circle C to the center of the circle P, which means that is some sort of radius. So we know that whatever formula that we end up using, we're going to be using one with radius. The next thing to look at is what this other segment AB is. The segment AB looks like it goes from the edge of the circle to the edge of the circle. So that sounds like this one, a segment whose endpoints lie on the circle. According to our vocabulary words, that particular word is, and I'm trying to find the vocabulary word in my little helpful cards here for you, but go ahead and scream it at the screen now if you already know what that definition is. I seem to have passed it. Where is it? Where is it in my little cards? You can't see, but off screen I'm flipping through all my little cards here. I'll show them. See, I'm flipping through these cards, trying to find, oh, there it is. That segment whose endpoints lie on the circle is a chord, so AB is some sort of chord. But notice that AB contains point P, which is the center of the circle, which means that AB is some chord that contains the center of the circle, and that is a diameter. So we have a radius that we have information about, and we have a diameter that we have information about. So please go ahead and calculate that now. Feel free to look back at the video talking about radius and diameter formulas if you need some help setting up those formulas. Okay, continuing on, let's look at 7 and 8. The directions there say find the diameter and radius of a circle with a given circumference. Again, go take a look at the walkthrough video for calculating circumference. We did a couple examples where we found the diameter, the radius rather, given the circumference. So you have 2 more practice problems just like this. I'll put a link on screen to that video so that you can see it. All right, question number 9 and 10, they want the exact circumference. If you've already watched that walkthrough video, you will know that what we mean by exact circumference is that it needs to keep the value pi involved. So please make sure that when you do that particular item, that you make sure that you keep the value of pi in there. Okay? So let's take a look at this figure for 9. This figure for number 9 is showing a circle. We don't know the name of the center, but we can see the center is drawn there for us. We also see inscribed within the circle that this circle has what looks like a square inside of it, or at least some sort of rhomboid, some sort of rhombus-like figure. And I can tell that it's a rhomboid, a rhombus-like figure, because this is a quadrilateral, has 4 sides, 1, 2, 3, 4, and all of these sides are congruent, which means they have the same measures. Also looks like there's a diameter that is cutting this figure in half. Now the thing that I know about all diameters in a circle is that they're all congruent to each other, which means that I could add in another diameter right here. Now, adding in that second diameter that wasn't drawn for us, but knowing that I'm allowed to draw any segment between any 2 points at any time that I want, yes, you're allowed to do that, means that I can say something else about this quadrilateral 4-sided figure that appears there in the circle, inscribed within the circle. All diameters are congruent to each other in a circle. And these are also the diagonals of this quadrilateral, this rhombus. Now, in looking at these diameters being congruent, I can go back into my notes and look at some of the quadrilaterals and see if I have any special quadrilaterals where diagonals are congruent. So here we go. I'm looking at my parallelograms because that's where my rhombus is, and it might be here. So rhombus's diagonals are perpendicular. That doesn't help. Square, 4 right angles, 4 congruent sides doesn't help yet. But if I look here under rectangle, it says that diagonals are congruent. And so because this quadrilateral has congruent diagonals, this figure, which I had already said was a rhombus, is also a rectangle. This is important because it allows us to say that these angles right here in the corner are right angles. Which means that if I ignore everything except this little triangle that's built right here out of the diagonal and these 2 chords, I can then use that to help me calculate some information about this circle. All right, let's go ahead and start our calculations. I'll walk you through this as much as I feel that you may need it. We'll set up certainly a lot of those formulas that you will need. Okay, what I've done here is I've just grabbed some line sheet of paper so I have some lines to draw on. You don't need lines to do these calculations if you don't want to. Alrighty, so here we go. I know that I've got some sort of right triangle sitting here. Clearly not drawn to scale, but I know that each of those legs are congruent to each other. They're both 3 centimeters, and I'm pulling that from this figure right here. All right, which means I want to find first the diameter, because since I want the circumference is given to me by the formula circumference equals pi times diameter. If I can figure out what the diameter is, or rather what the length of this side of my triangle is, then I can figure out what the exact circumference of this circle is. Let me zoom in a little tighter here on my work so you can see it. Noting that this is a right triangle, I know that the Pythagorean theorem must hold, which says that a squared plus b squared equals c squared. Now I know the letters are getting used over and over again here, and it's because I've run out of English letters to denote different things. Circumference and circle both start with the letter C, which is why I'm capitalizing the C when I'm talking about its circumference. This lowercase c is talking about this right here, the hypotenuse. Always C in the Pythagorean theorem is referring to the hypotenuse. The letters A and B are the other legs of my right triangle. And so I'm going to go ahead and just start substituting away. So Here's A is 3. I'm going to do that substitution. The rest of my equation I'm going to leave the same. I've gotten to the letter B, so I'm going to replace it with its number. Again, 3 because that is congruent to the first side. Now I'm going to replace the letter C with, you know what? I'm just going to use C again because I don't know what that value is yet, but that's the one I'm interested in. So 3 squared is 9. 3 squared is 9. Whatever that is C squared. 9 plus 9 is 18. And so C squared is 19, or 18, excuse me. I don't care what C squared is. I want to know what C is. In this case, the square root of 18. But notice that we were asked for exact values, which is what was requested in the directions, exact circumferences. Which means that if right now I drop the square root of 18 into my calculator and get a bunch of decimals, I am not going to get an exact value, which means my work isn't done. I need to simplify this radical. Link on screen to a recall video that talks you through how to simplify radicals. I'm going to go ahead and finish out this example for you here. So looking to simplify this radical, I'm going to think of 18 as how much the different factors that it has, the different numbers that you have to multiply together in order to give you 18. I get 18 from 9 times 2. Now that I've got factors in there, I'm going to look at them and notice that 9 is a perfect square. It comes from 3 times 3, which means that this is in a helpful state, and now I can break this radical, in which the radicand, the thing inside, are being multiplied together, into 2 different radicals where the radicals are being multiplied together. Notice that each factor in the radicand is now in its own radical. Radicand, the thing inside, radical, the big symbol that encompasses all of it. Square root of 9 is just 3. Notice that when you do that calculation, the square root goes away. Square root of 9 is 3, not square root of 3. And then the next one is the square root of 2. That isn't a whole number, so I'm going to leave it as is. And so C, not uppercase C circumference, but lowercase c, the hypotenuse of that right triangle that we identified that we had, is 3 times the square root of 2. All right, fantastic. We now have a bit of information. Let's look back at our figure really quick. I'm going to shuffle some things around so that we can see the figure and the work. So that was the measure of this segment right here, the diameter of my circle. The diameter of my circle is 3 square roots of 2, which means back in my circumference formula up here, I can replace that d for diameter with 3 times the square root of 2. Whoops. I didn't realize that was off screen. Sorry. Now this looks a little messy and jumbly. We normally like to put letters or symbols that are numbers that are being represented by some sort of letter. Yes, even the Greek ones. Kind of at the tail end of all the multiplication stuff. So while this is the correct way to write it, like this is the correct value in terms of what it means, it's not written as neatly as we want it to be written. So we're going to bring these that have all the numbers up to the front, and then write that Greek letter pi, representing that 3 point whatever number, at the very end. And so this would be the exact value for the circumference of this circle, which contains an inscribed square, side length 3 centimeters. Similar process gets used here for number 10, but notice it gives you the right triangle already listed. This 8 feet is for this short side of what must be a rectangle. And then this 15 is for this chord, which must be the long side of the rectangle. So very similar concept. You likely have to use the Pythagorean Theorem to calculate some side of some triangle that's got some information that then you can use to either get a radius or diameter of the circle, and from there find the exact circumference of the circle. Be wary of any radicals that might happen, which means you're going to have to reduce these radicals down. And when you substitute it in, do not push the pi button on your TI Inspires. Do not substitute the number 3.14, whatever you decide to use, for the value of pi. Just leave it as its Greek letter pi as the symbol. All right, and that is the full walkthrough for section, or the worksheet, 110. I hope you found that helpful, and we'll see you in class.